Good morning, student friends. In this lecture, we will see part 2 from second chapter, that is melting and pouring. In this particular chapter, we are going to study various types of furnaces used in the foundry industry and how the pouring operation is carried out in the foundry industry. That also we have to focus. Now, first is the selection of the furnace for a particular application. It depends on the below criterias. First is the initial cost of the furnace. We have to study the initial cost of the furnace. If we are considering the electric furnaces, means if we are using electric energy as a fuel for operating of the furnace, we have to give a more price. That is, initial cost of the electric furnaces is more as compared to coke fired and oil or gas fired furnaces. That is the first criteria of selection, that is initial cost. Second is fuel cost. Electric energy, if we are using as a fuel, at that time cost of operation will be more. That is, fuel cost is more in case of electric fired furnaces as compared to coke and oil or gas fired furnaces. Type of metal or alloy to be melted. Cupola furnaces is used for melting of cast iron. Malleable cast iron, nodular cast iron or grey cast iron is melted by using a cupola furnace. Induction furnace is used for melting of steel. And electric arc furnaces, that may be direct arc or indirect arc furnaces, that are used for melting of steel as well as cast iron. Melting and pouring temperature achieved in a case of cupola furnace is less as compared to induction furnace or electric arc furnaces. Means more temperature you will achieve in case of induction and electric arc furnaces as compared to cupola furnace, because cupola furnace operates on coke and induction furnace and electric arc furnaces are operated on electric energy. That's why amount of temperature will be more. Quantity of metal to be melted. Cupola furnaces is used for maximum melting of 15 ton of the metal per heat. Per heat means 16 hours of a heat. And electric arc furnaces, that may be direct or indirect, they are melting a metal up to 125 ton maximum capacity. And induction furnace is a small capacity furnaces, and in a batch type we have to carry out melting in case of induction furnace. But cupola furnace and electric furnaces, they are operated continuously. That is, quantity of metal to be melted. Method of pouring desired. Induction furnace, from induction furnace we are taking out molten metal by tilting it, but from the cupola furnace we have to remove the metal at the tap hole which is provided at the bottom. At bottom there is a hole, and through that hole we have to take out the molten metal. But electric arc furnace or induction furnace, that we have to tilt and we have to taken out the molten metal. Cost of furnace repair and maintenance. Furnace repair and maintenance cost is low in case of cupola furnace as compared to induction furnace. But because induction furnace, in case of induction furnace we are using heating coils, and the material of the heating coil as well as its manufacturing cost is more, installation cost is more. That's why maintenance and repair cost is more in case of electric arc furnaces as well as induction furnace as compared to cupola furnace. Chances of absorbing impurities by the molten metal are maximum in case of cupola furnace, because molten metal comes in direct contact with the heating element, that is fuel. When there is direct contact of fuel and the metal to be melted, there is maximum absorption of impurities, and it is happening in case of cupola furnace. But induction furnace and electric arc furnace, there is no direct contact of fuel element with the metal. That's why impurities are less in a case of induction furnace and electric arc furnaces. Speed of melting the alloys. Induction furnace or electric furnaces are having maximum speed of melting the alloys as compared to cupola furnace, because cupola furnace is operated on the coke, and coke will take maximum time to reach the stage of maximum combustion. That's why melting time is more in case of cupola furnace. Degree of cleanliness and pollution. Again, it depends on the type of fuel we are using for melting of the metal. Obviously, coke is making more pollution as compared to electric arc furnaces as well as oil and gas fired furnace. Various gases are generated by the combustion of coke, that may be carbon monoxide, nitrogen oxides, sulfur oxides, and all these gases are harmful to the society. That's why degree of cleanliness or pollution level is more in case of cupola furnace, because which is operated on the coke, and it is very less in a case of induction furnace or electric arc furnace, because we are using electric energy as the fuel element. All these are the criteria for selection of the metal, for selection of furnaces for a particular application. Now we will start the cupola furnace, that is the first furnace. This cupola furnace, now in this PPT you can see grey cast iron. For melting of grey cast iron we are using cupola furnace, air furnace, rotary furnace or electric arc furnace. For melting of a steel we can use high frequency induction furnace, electric arc furnace or open hearth furnaces. All these furnaces are mentioned according to the type of metal to be melted. Now first furnace is called as a cupola furnace. In 9th standard we have studied this cupola furnace, and in Marathi we are calling this furnace as a Jhot Bhatti. The capacity of this cupola furnace is ranging from 1 ton to 15 ton. Height is about 6 meter. Maximum height of the cupola furnace is about 6 meter, and it has a diameter of 75 centimeter to 2.5 meter. Now this cupola furnace is used for melting of nodular cast iron, malleable cast iron or grey cast iron. Whatever metal you are getting from the cupola furnace does not have a uniform quality, means each time you will get a different chemical composition. That is a problem of cupola furnace. And loss of alloying elements takes place, like a silicon and manganese, their loss is taking place. This particular cupola furnace we can use for duplexing and triplexing operation. Duplexing operation means two cupola furnaces are connected to each other. Output of one cupola furnace is input to the second, that is a duplexing operation. And triplexing operation means three cupola furnaces are connected to each other, and all these things are done for melting of steel. In rare cases we can use this cupola furnace for melting of the steel also, because while melting a steel we need to have a uniform quality of the metal or pure quality of the metal, but this is achieved only by duplexing and triplexing operation. Now we will see its construction. Height is about 6 meter, diameter is 75 centimeter, inner diameter is 75 to 2.5 meter, and the cupola furnace is made up of a steel shell. Generally we are using boiler quality material for this steel shell, which is having a thickness of 6 to 12 mm. In industry also we are using a small capacity cupola furnace, and these are called as a cupolits, which capacity is half ton to 1 ton capacity, and height is 2.5 to 4 meter. Now at the bottom this cupola furnace is supported on the cast iron legs. You can see in this picture blue color, these are the legs which are made up of cast iron, and they are used to support this cupola furnace. 4 legs we are using for its supporting. It is having bottom plate which is also made up of cast iron, which is placed above the steel, which is placed above these legs, and above this bottom plate we are making a ramming of the molding sand. Here ramming of the molding sand is making, because this yellow color indicates the molten metal. When this metal comes in contact with this bottom plate, it is going to melt, and to protect this bottom plate from high temperature of the molten metal we have to make a covering, or we have to make a layer of refractory sand on the surface of this bottom plate. And all these steel shell you are seeing here, it is a cylindrical shell. It is having 6 to 12 mm thickness, inner diameter is 75 centimeter to 2.5 meter as per the capacity, and height is about 6 meter. This steel shell is lined with refractory bricks. You can see at the center you are seeing the red color bricks are there. These are the fire bricks or refractory bricks, and these bricks are used to protect this steel shell from very high temperature of the molten metal. Generally we are achieving 1650 centigrade temperature by using this cupola furnace, and we have to protect this steel shell from very high temperature of the molten metal. Now above this bottom plate, this is called as a tap hole. After melting of the cast iron or the metal charge inside this cupola furnace, it is taken out from this tapping hole. Through the tapping hole we are taking out the molten metal. It is collected in this pouring ladle, and it is taken to the pouring station. This tapping hole is used to remove the molten metal from the cupola furnace. Now above this tapping spout, this cupola furnace is fitted with these circular pipes, and these pipes are used to supply compressed air to the combustion of the coke. Combustion of the coke is achieved by supplying compressed air through this pipe inside the cupola furnace. Now this CFM you are seeing, this C means coke, flux and metal. Adding of alternate layers of coke, flux and metal through this charging door inside this cupola furnace is called as a charging of cupola. Adding of alternate layers of coke, flux and metal in the cupola furnace through this charging door is called as a charging of cupola. This here water pump is used to lower down the temperature of this shell. This shell we have to protect from high temperature of the molten metal. That's why water is also circulated around this steel shell. This steel shell is having thickness 6 to 12 mm. That's why it is lined with fire bricks from the inner surface. You can see in the cut section, these are the fire bricks, and water is also circulated around this cylindrical shell to protect it from very high temperature of the molten metal. Above this tap hole here, one small hole is provided, that hole is called as a slag hole. After burning of this flux, slag is formed, and that slag is impurity in the molten metal and which is to be removed. For that purpose, above the tap hole, near about 25 centimeter above the tap hole, slag hole is fitted, and through that slag hole we have to remove the slag. Slag means impurities present inside the molten metal, and that slag is having lower density. That's why it floats on the surface of metal. Metal has a more density, that's why it is at the bottom, and slag is removed, and that action is called as a slagging. And molten metal is removed through this tapping hole, and that action is called as a tapping. Adding of alternate layer of coke, flux and metal through the charging door inside this cupola furnace is called as a charging of cupola. Now this is the fire bricks lining, this is the steel shell, and at the upper side this cupola furnace may be open or it has a fitted with spark arrestor. Means whatever gases are generated due to combustion of coke, these gases are carbon dioxide, carbon monoxide, nitrogen oxides, sulfur oxides. All these gases are harmful to the environment, and all these gases we have to trap. For that purpose, this spark arrestor is fitted at the top. Again we can have arrangement as a precipitator filter arrangement, so that you can filter out harmful gases and we can spread less harmful gases to the environment. Various types of fluxes we are using, that is calcium carbonate, sodium carbonate or calcium carbide. All these are the fluxing material. Function of the flux is to lower down the temperature melting point of the slag, as well as to protect the molten metal from getting oxidation. Again to remove the impurities present inside the molten metal, that is again the function of flux. Coke, in this cupola furnace we are using good grade anthracite coke, which is having a low sulfur content, because if coke is having more sulfur content, that sulfur is going to be absorbed by the molten metal, and unnecessarily sulfur percentage of the metal increases, and which will change its mechanical properties. That's why good grade low sulfur coke also we have to select. Again that sulfur is causing a environmental pollution, because sulfur oxides may be formed, that is sulfur dioxide or sulfur trioxide. Sulfur trioxide is responsible for the acid rain, and sulfur dioxide is responsible for various health diseases related to the our respiratory system. All the both gases are very harmful. That's why we have to select the coke which is having a low sulfur. And here metal charge consists of pig iron 30%, steel scrap 30% and returns 40%. That we have to select as a metal charge. Returns means whatever scrap is generated in the foundry industry is called as combinedly returns, and that returns we have to add in the amount at a 40%, pig iron 30% and steel scrap 30%. This consists of a metal charge. This is the construction of the cupola furnace. Now in detail you can see here, I told you at the bottom this cupola furnace is having a legs. These legs are made up of cast iron. Again it is having bottom plate which is covered with sand, because this bottom plate we have to protect from very high temperature of the molten metal. This is called as a tapping hole. Tapping is the action of removing molten metal from the bottom opening of the cupola furnace is called a tapping hole, which is molten metal is taken inside this pouring ladle, and from the pouring ladle it is poured into the mold cavity which is already been ready. Above this tap hole, this circular hole is called as a slag hole. Function of the slag hole is to remove the slag which is generated due to burning of flux. Slagging action is carried out through this slag hole. Above the slag hole, here square holes you can see, these are called as the tire holes. Function of tire hole is to supply air evenly to the combustion zone, because in our rural area we have seen the blacksmithy person is coming, and the wife of that blacksmith person is continuously supplying compressed air, so that the burning action of that coke is enhanced. Likewise also here burning action of this coke will be enhanced by supplying of the compressed air through this tire hole, and these tire holes are connected to this air blast inlet. This wind box and air blast inlet, their function is to supply or to connect compressed air pipe to these tire holes. Now this is the fettling hole. Fettling hole means maintenance and repair of this cupola furnace is carried out after each heat, and for that purpose the human being or the worker has to enter from this fettling hole inside this cupola furnace, so that whatever this fire breaks hatching line you are seeing to this shell from the inner surface is called as a lining of fire bricks, and after each heat there may be chances of damaging of this fire bricks, which is removed from after before start of the next heat. Now here 1 2 3 you are seeing, that is alternate layers of coke, flux and metal, and these coke, flux and metal, their alternate layers are added through this charging door. This hatching line is covering of the steel shell from the inner surface to protect it from very high temperature of the molten metal by using a fire bricks. At the top it is having a spark arrestor, so that you can arrest the harmful gases before, or you can make filter of that gases before they are escaping to the environment. This is the refractory lining you can see. This is the steel shell which is having 6 to 12 thickness. Again material is boiler quality material, that is SA516 grade 70, and this stage is the limit up to which we have to carry out charging of the cupola furnace, means adding up alternate layers of coke, flux and metal. That operation we have to carry out up to this stage only. Now this cupola furnace is having various zones, that is well zone, combustion or oxidation zone, reducing or carburizing zone, melting zone, preheating zone and stack zone. All these zones are present. Now this well zone, well means kai, in Marathi we can calling it as a vihir. After melting of the metal it is accumulated in this well zone, that's why this zone is named as a well. Well means vihir, molten metal well is created, it appears like a well, that's why it is called as a well zone. Here for this tapping hole we are using a refractory plug which is initially inserted into this tapping hole. Above this well zone is called as oxidizing or combustion zone. Whatever oxygen is coming from this tire hole, it is absorbed completely in this oxidizing or combustion zone. Combustion means maximum temperature is achieved, exothermic chemical reactions are taking place in this combustion zone, and near about 14,452 BTU heat is developed. BTU म्हणजे British thermal unit, and oxidation of silicon and manganese takes place in this zone, that's why this zone is called as oxidizing zone. Above this combustion or oxidizing zone there is a reducing or carburizing zone. Reducing means whatever carbon dioxide is created in this combustion zone, it is reduced to the carbon monoxide, and endothermic chemical reaction takes place, that's why temperature is less in a case of reducing zone as compared to combustion zone, and it is also called as a carburizing zone because carbon which is present in the coke, that carbon reacts with the carbon dioxide and it is a forming twice CO, that is CO2 plus C, that gives twice CO. CO means carbon monoxide. Carbon dioxide is reduced to the carbon monoxide in this zone. That's why this zone is called as a reducing zone. Or carburizing zone means carbon is absorbed by the molten metal inside this zone and unnecessarily brittleness of the material increases. That's why this zone is called as a carburizing zone. Above this, reducing zone is a melting zone. Metal droplets you can see in this melting zone. Metal droplets you can see in this zone, and here um, ferrous carbide is formed. Ferrous carbide is formed in this melting zone, and near about 1600 degree temperature you can achieve in this melting zone. Above this melting zone is a preheating zone. Function of preheating zone is that whatever layers of the charge we have added, coke, flux and metal, in this preheating zone it is a preheated means before melting, that layers of the coke and flux as well as metal, they are preheated. That's why this zone is called as a preheating zone, means whatever heat is emitted in this case, in case of combustion zone or melting zone, that heat is absorbed in this preheating zone by the charge. And stack zone means gases generated due to burning of coke, that gases are accumulated in this zone before they are escaping to the environment. That's why this zone is called as a stack zone. All these are the zones of the cupola furnace, that is well zone, combustion or oxidizing zone, reducing or carburizing zone, melting zone, preheating zone and stack zone. All these zones of the cupola furnaces are having various reaction, and their temperature is different, and the level of that layer is also different. Here we will stop with the cupola furnace, and in the next lecture we will see the induction furnace.